From the beautiful South Studios of Way Happy, this is Mr. Meyer, and we are going on to finally talk about maybe some of the shortcuts to differentiation. Now, you have done the different quotient, and you've done it a million times, right? And so now we're going to talk about, all right, how come some people can all of a sudden tell us a derivative so much faster, and they're obviously not doing that stuff in their head. So here's some of the rules, and there's a lot of them, and so we'll just take our time and go through some. So first one I'm going to show you is called the constant rule, which you can see right here. This is the constant rule right here. And what it says is that if you take the derivative of a constant, then the answer is always 0, which makes sense. If you look to the right a little bit, you might notice here that a constant would just be a horizontal line, right? And the derivative is the slope at any given point. Well, at any given point, the slope is 0, right? At this point, the slope is 0. At this point, the slope is 0. At this point, the slope is 0. So wait, no matter where you go on that line, the slope is always 0. And that really does kind of help us say, okay, the slope and the derivative, they are a nice little relationship that we are now studying. So look at this. It says if y is equal to 7, this asks what's the derivative? What's the dy dx? It's 0. This is another way I could say it. If f of x is 0, hey, look, then f inverse, the derivative, is 0. Here is s of t, then s prime of t, the derivative is 0. And even if this stuff is all constant, pi is just a number, that's a constant, k is, they tell you, is a constant. So guess what? If that's y prime is 0. So you can see that on every single one of these, the constant, the function was constant, and therefore the derivative was 0 every single time. And it makes sense that the slope would be 0. All right, here's the power rule, the famous power rule that people have been wanting. You can read it right here. It says if you have a function that is x to some power is differentiable, then the derivative is, look at that. You see what happened? The n came out in front, so the exponent came out in front, and you power the exponent down by 1. And that is how you do it, right? So let's give it some tries. So notice, and you got to get really good with exponents. So here's a real simple one, example 2. If I tell you that f of x is equal to x plus 5, and I want you to find f prime of x, then you could either do the big difference quotient, or you could just remember that, hey, the exponent comes out in front, so 5 times whatever's in front is 5x, and then power that exponent down by 1, 5x to the 4th, and there's your derivative. What? I tell you, try it. Try it with the difference quotient, and you'll see it works really well. Again, you got to get good with your exponents. So like, look at the next one. That's not an exponent, right? Because there's a cube root. So do you remember how to clean that up? Well, sure. I know that this would be x to the 2/3 power. Now, how do I remember that? 2 is the power and 3 is the root. And remember, like a tree, roots are on the bottom. So 2 is the power, 3 is the root. That's what it would look like in exponent form. So another way to write f of x would be to write it like that. Well, now you want the derivative of that piece of cake. I'm going to bring 2/3 out front, and then I'm going to power the exponent down by 1. So this got a little sloppy here. X to the, now what is 2/3 minus 1? Really just erase. 2/3 to the x, and then 2/3 minus 1, what is that? Negative 1/3 power. So it would look like that. Or if I could clean that up, negative exponent means move me to the denominator. So 2 to the 3x to the 1/3. And oh, wait, 1/3 power, that means 1 power and 3 root. So how about 2 over 3 cube root of x? And there is your derivative. Now, I guess any of these could have been your derivative, but there is your derivative. And you have now done example 3. All right, let's see example 4. Example 4, find that one. So there's another one I can rewrite, f of x. That's weird that the exponent's in the denominator. Oh, wait, no, that's not weird. I'll just make it to the negative 4 power like we did up above. So I can bring them up and just make the exponent negative. So there's your function. So now if you want the derivative, what's called the inverse, you want the derivative, then I'm going to bring the exponent out front, and then I'm going to power it down by 1. So negative 4 minus 1 is negative 5. So that would look something like negative 4 over x to the 5th. And there is my derivative. Now, again, what is a derivative? A derivative is the slope, is the equation of the slope of the tangent line at whatever given x you want. So wow, we just found that weird equation, and I could tell you the slope anywhere, and we'll explore that a little bit with some graphs. But let me ask you a question, and we'll be right back. All right, nice work on those ones. All right, so how about the constant multiple rule? That just says, all right, if you have a constant out front, it's not really that different from the power rule, except for it's just telling you if there's a number out front, then feel more than free to multiply the constant by the derivative of the function. So, and you can see that right there. I'll highlight it in green, right? But look at that right there. It says take the constant and multiply it by the derivative. So if I wanted to find out what dy dx was, the derivative, then I could go ahead and solve that by saying, hey, I'm going to take the 5 and then I'm going to take the derivative of x to the 7th, right? So the derivative of x to the 7th, which I don't know how I'm trying to write that, which is ugly, but the derivative, the entire derivative would be 5 times the derivative of x to the 7th, which would be 7x powered down by 1/6, right? So what is that? 35x to the 6. So you can take that constant if you want, put it out front, take the derivative of the second part of the x part, and then multiply those together. So same thing here. I could make this 4/5, right? I'm trying to find g prime. I should probably label it. I have 4/5 times, well, gosh, man, I'm just not on it, right? G of x, I would say, is 4/5 times 1 over x cubed, which is equal to 4/5 times x to the -3. Now, you probably could have done most of that in your head, but I wanted to show you at least the steps. Now, if I'm going to go ahead and take g prime of that, I'm going to say, all right, I'm going to take 4/5 out front, and then the derivative of this, which was what? -3x to the -4. There's the derivative of x to the -3, right? Using the power rule. And now just multiply it all together. So I know it's a -12/5 x to the -4th. That means move it to the bottom. So -12 over 5 x to the 4th. And there is your constant multiple rule. Multiply the derivative with the constant out front. That was mighty fine. And here's probably the last rules we are going to hit. They're called the sum and difference rules. And what do they say? They say that you can do the derivative separately. Look, here's f plus g, and we're taking the derivative of it. Well, you can take the derivative of f and the derivative of g and just add those suckers together and be one happy camper, right? Same thing with subtraction. So it doesn't matter if it's addition or subtraction, which makes it super nice, I believe. So look at this. If I have this ugly function right here, I don't want a highlighter. Thanks, though. Wait, I go back here and I'll go pen. If I want to do that function, I want to find y prime. Well, piece of cake. Just do each one individually. So, because they're all added together, I'm just going to do each one individually. Y prime is going to be, take the derivative of that, 3x squared. Take the derivative of that. Ooh, there's a constant out front, so be careful. So is that 8x to the first? Take the derivative of that. 1 comes out front, and then you get -2x to the 0, but no one ever writes x to the 0. And oh, look at that. There's a derivative of a constant. We said all the constants are 0. So there is your derivative. Beautificent. What else could we do? How about the next one? I see that one as 3 over 16x to the 4th, right? Because it was 2 to the 4th, x to the 4th, minus 1/2 of an x plus 1/4. So I didn't do any derivatives or anything yet. I just kind of rewrote it. And in fact, I'll even make that 3/16 x to the -4 minus 1/2 x plus 1/4. So I just cleaned it up a little bit. So now I could find g prime, and that should be wonderful. G prime would be, just looking at this now, right? I would say it's 3/16, and then I'm going to take the derivative of x to the -4, so -4x to the -5th. All right, and then the derivative of the next one is minus 1/2, now x to the 0, and then the 1/4, that's gone. So there's my derivative. I can clean this up a little bit. Let's see, 4 goes into 16. That's going to go in 4 times. So that is going to be 3/4. Oh, look, there's an x to the -5th. So let's put the x to the 5th down at the bottom and subtract off a half. And if you want that to look a little more likable, 4x to the 5th minus a half. You look gorgeous. I don't know, I guess I feel like I could clean that up by getting a common denominator and maybe making it look a little prettier, which I wouldn't mind doing. Here's an example. I thought this is the last thing as I'll do, but I think that last one, number 10, I see I can FOIL and stuff like that. But this one's kind of fun. It's like find the equation of the tangent line. And that could be something fun to do to you guys, is because what do you need? You need a slope and a point. And so we could figure out where that point is by plugging x in and getting x and y. And we could take the derivative of f to find the slope. So it wouldn't be such a big deal, right? If I did this, f prime of x would be, don't get weird on me, 12x squared minus 6, and then there's no more. So that's going to get us the slope, and we want the slope at 2, so let's plug it in. That's going to be, gosh, what is that? That's 4 times 12 is 48, minus 6 is 42, so the slope is 42 at that point. That's a huge slope. And what point are we talking about? Well, we know we're talking about the point 2 comma something. We got to figure out what the something is. Oh, wait, that just means we plug it in here. So if I plug a 2 in for these x's, I'm going to get 8 times 4 is 32 minus 2 times 6 is 12. So that's 20 plus 5 is 25. So it's that point. And lo and behold, the equation of the tangent line would be y minus y1 equals mx minus x1. And I think a really cool exercise would be to graph this on Desmos and to graph this on Desmos, and you should have a tangent line. Maybe we'll do that in class, or maybe an example. I don't know. All right, have a great day. Stay happy, and I'll see you tomorrow.